In this video, we're going to continue on talking about stacks. So the first video, part one of the stacks and queues, we just talked about the general ideas of both stacks and queues. Okay, so for each, remember, they're restricted data types. We'll talk about the differences as we go along. Each of them can be implemented either as an array or as a linked list. So I think I'm going to do 4 videos to make them shorter. So starting off with stacks as arrays. Okay, so we can use the array to hold our stack, or a queue for that matter, because arrays only have one data type and stacks only hold one data type. So we don't need the option to have mixed data type. So we should be okay with that. Okay. So storing in the array has the advantage of being a little more straightforward to code. You don't have to deal with all of that linked list code. It's a built-in feature, and that should be good. The problem, though, the problem we always have with arrays is that we have to allocate a contiguous block of memory before we start. And we may or may not know how big that needs to be. So that can certainly be a concern. It can be less efficient than if we use the linked list, which we'll do in the next video. Okay. So the way we're going to do this, and when we get to queues, it's a little more complicated, but it's pretty straightforward with stacks. Okay. So we're going to assume that the stack top is going to expand to the right as we add items. Okay. So in the initial configuration, we're going to use, so even before that, let me mention, we're going to use a integer variable called stack top. That'll always be an integer no matter the type of the stack. That refers to one plus the top of the stack, okay, or one more than where the stack will be located at, okay? And that one more becomes important in dealing with the very first element, okay? So when we first initialize it, we'll have our stack top equal to 0. It also, when we do it this way, the length of the stack is 0, okay? Then as we add the first element, we'll add it at stack top, okay? So stack top is the next element to be added, okay? It's one index beyond where the real top is located at, okay? So in this case, it's empty. When we add one, we're adding it. So let's take a look at my example here, make it kind of a living example. Okay, so if we're going to add the following 9351 into the stack, okay? So when we start this, the initial condition is that the stack top is equal to 0, okay? When we go to push the 9 on, we're going to add 9 at this stack top position, okay? So 9 gets added there. We're then going to increase the stack top to 1, okay? So the length of the stack is 1. We get to the top element by looking at stack top minus 1. So the list is what the array we're holding of stack top minus 1 is going to be equal to 9 at this point. Okay, so that's the list of 0. 1 minus 1 is 0, okay, for 9. Okay, we go to add the second element, stack top's equal to 1. We're adding the 3 at position 1. This is at list 1. Okay, this now goes to 2. Again, if we want to get the list stack top minus 1, that's going to be 2 minus 1 is 0, which will point 2 minus 1 is 1, sorry, which points to 1 here. Okay. Then if we were to add the next one, we're going to add it at position 2. And I guess I could put that this is at 0 index wise. Super clear. This is 1, 2, 3. This is 4. And this is 5. That's all we need. Okay. So that's the position that we're at. Okay. So we go to add the third element, which is a 5. We're going to add it at stack top, that position at list stack top. So list stack top is here. Okay. It's going to put our 5 right here. We're then going to increase the stack top to 3. Okay. And if we look at the list at stack top minus 1, 3 minus 1 is 2. That would give us the 5. Okay. And finally, we're going to add one more. We have a 1 here. Okay, so that's going to give us, that goes to 3. This goes to 4. And then our last element here is the 1 here. Okay. So that's when we're adding to it. Getting a so we also have to make sure, since we're going to allocate memory, we're going to have a maximum stack size. We have to deal with that. If the stack top is equal to that maximum, then we know it's full. If stack top is equal to 0, we know that it's empty. Okay. When it comes to returning that top value, the top value is always at the list of stack top minus 1. If we want to remove that element, we want to do a pop. Okay. All we have to do, we don't delete anything. I mean, we've already allocated the memory. We can take the stack top minus 1, make this a 3. Okay. The stack top is now at 5. Okay. And if we wanted to add another element, add a 9, well, let's do something else. Let's do a 7. That 7 would get added in that position. Okay. So we're able to fully utilize the amount of memory that we have. Okay. That's the basic idea. So let's take a look at the code here of how this gets implemented. Okay. So we're including here, it's probably a weird shape if you're on a phone. So let me make it a little bit more normal. Okay. So we're starting here with including the stack ADT.h. Remember, that is going to put in those pure virtual functions for the initialized stack. The is empty, is full, the top, the pop. I think that's it. Anyway, whatever those main functions are. Okay. So yeah, right here. Push. That's what I was missing. Push, top, and pop. Okay. So all of these are the ones that are mandated. They're an obligation from including the stack ADT.h. They have to be implemented and they have to have these prototypes, okay, or these numbers and types of parameters. Okay. So we're also defining up here, we're reassigning the equals operator. Okay. So we're going to use it to be able to make a deep copy, not a shallow copy. Then we have the prototypes for all the ones that come from the obligation of being part of ADT. We then have a constructor. We have a copy constructor, which means we can use an existing object to make a new copy of it. And then we have our destructor. Okay. As far as the things that we need, the member data to keep track of things, we have an integer for the max stack size. Okay, so that's going to be how big the stack can be, how many elements it can hold. We're going to have the stack top, which points to the top of the stack. Remember, it's 1 beyond the top. That also serves as the length. Okay, we're then going to have a list or an array. We're going to call list. It's going to be a pointer to an array that holds all the stack items. So it's going to be of type with a capital T. Okay. We're also going to create as a private function. It's going to be used by the copy constructor and the equality sign. We're going to create this copy stack function. Okay. It's going to take an existing stack and another stack and make a copy of it. Okay. So to define these starts off pretty simply with our initialized stack. Whatever is in the stack, we initialize it. We're going to set the stack top equal to 0. It means that we can't trust what's beyond stack top in the array. It's stuff that we've deleted, but we just really renumber it. Okay. That's all we're doing there. Is empty is pretty straightforward. We look at the logical expression, does stack top double equal 0? If that's true, we return that. If it's true, it's true. If it's false, then it's not empty. Okay. And the same thing with the is full stack. We're testing stack top against the maxed stacks size. Okay. We then have the push. So push is going to take an item of type. Okay. Reference to that. It's constant because we don't change the item we're pushing on to the list. Okay. So we're starting here. We're going to say if not is full stack. Again, if the stack is full, we can't add to the full stack. So the else part here Going to tell the user that message. Okay. If not, we're going to let list stack top be equal to the new item and then increase stack top by 1. Okay. So for the top, we're going to use an assert statement here. Remember, the assert is going to evaluate the expression. If it's true, great. If it's not true, it's going to throw an error. Okay. Or it's going to stop the program and throw an error, an assert error. So for the top, we're asserting that the stack top does not equal to 0. So it's not an empty stack. Okay. If that's the case, we're going to return the list item stack top -1. That's where the actual top is located. Okay. We have the pop then. Okay. So this is where we're going to actually remove the item. Okay. So we're going to start again, trying to see if it's an empty stack. If it's an empty stack, then we can't remove from an empty stack. You can't remove something from nothing. Okay. So we have that to worry about. So if it's not an empty stack, we're simply going to decrement the stack top, move it by 1, and it's in terms of this stack, it has been deleted. Okay, even though we're not really deleting anything. So here's that helper function, that copy stack, and what it's going to do basically, it's going to go through. Okay, and it starts by deleting the list of the stack we're copying into. Okay, so the other stack is going to become this new stack. We start out by wiping that one out. Okay, getting rid of that memory. We're then going to let the max stack size be equal to whatever the other stack's max stack size is. Okay, so it could be different from what we had, but we've deleted it, so we don't care. We're then going to let the stack top be equal to the other stack top. Okay, we're then going to create a new list. Okay, of type with that max stack size from the other list. We then go through, we're going to loop through, and we're going to copy 1 by 1 each item through the list. Okay, other list gets copied to the list, what we're attached to. Okay, so here we have our constructor, stack type instructor. The constructor is going to take the stack size. We have to initialize it with that. Okay, so if the stack size is less than or equal to 0, we're going to throw an error message. If not, we're going to let the max stack size be equal to that stack size. Okay, first thing we have to do, we also have to set the stack top equal to 0. And now we have to actually allocate the memory for that array. So list is going to be equal to new type. The size is the max stack size. Okay, so now we've created that. Okay, our destructor, because we have memory elements, the list that we're holding, the array, is a memory variable. So we have to have a destructor where we're going to go through and delete that list. Okay. And we put the 2 brackets here, square brackets here, when the thing we're deleting is an array. Okay. It usually never puts the hurt that even if you're not sure if it's an array or not, because it'll work no matter what. Okay. Then we have here our copy constructor, which is going to take as a parameter another stack. It's then going to set the list equal to the null pointer and then do the copy stack. Okay. We do this as an outward facing version of the inward facing copy stack function. Okay. And we're allowed to tie that to a constructor with a different parameter. Okay. So this is, you've got a list called S2. Okay. You can create a new list called S3 that's a copy of S2. You would create S2 and send it the parameter, create S3, send it the parameter S2, which would then run the copy constructor. Okay. We're then going to redefine the equality operator. Okay. And when we do that, going to redefine the equal sign, which is the assignment operator. It's also going to run the copy stack. Okay. And we're making sure that we're not copying the same stack to itself. That's what's that about. Okay. And that's it for the stack implemented as an array. It's pretty straightforward. Okay. So now let's take a look at a simple sample test program. What do I call it? That's good. That's the question. I call it simple stack test. Okay. So in this case, we're going to include the stack.h. Okay. The stack.h is going to include the stack ADT. Okay. Um, so the book at various points calls this file mystack.h and stacktype.h. They're the same file. I just have two copies in case I ever confuse myself, but it doesn't really matter. Okay. So we're going to have this function here to test the copy constructor, okay, which is going to take a stack type that's of type integers, okay, other stack, okay. So we're going to use that to test that copy constructor. So this is pretty basic. We're just going to run through some of the functions. A full test would check every single feature, every single function we're creating. So what we'll see. So we're creating a stack type of integers called stack. Note that stack is not a reserved word. Okay, since it's not part of the language, we're building it in. Okay. Then we have another stack. So it's set to 50. We have another stack called copy stack, also initialized to 50. And then we have another stack of integers called dummy stack that is also, or that is actually set to 100. Okay. So we're starting with our stack. Okay. So the stack is going to be equal to initialized stack when we first start. Okay. We're then going to push 85, then 28, and then 56 onto the stack. So at this point, 56 is at the top. Okay. We're then going to copy. So copy stack, this is using the overloaded assignment operator. So copy stack is going to be equal to stack. So we're going to wipe out copy stack and copy stack to copy stack. That's weird names. I'm not sure why they named that. Okay. We're then going to go through and just print out. Okay. So as long as we're not at the end of the empty stack, we're then going to go through and print out the top, and then we're going to pop. Okay. And the reason we're doing this, if we think about this, if you have a stack, and most programmers do this at one point in their development, you create a stack, like, oh, I'm going to print it out. When you go to print it out, you have to destroy the list, or sorry, destroy the stack to print it out. Okay. So because of that, and especially since we have the overloaded assignment operator, we're just going to make a copy of what we want to print. So when we go to print it, it destroys the copy and not the original. Okay, so that's important to keep in mind. And again, it's because the pop is destructive as it goes along. Okay, so we're going to go ahead and print out the elements of the copy. Again, we don't want to print the original because that would kill it. Okay, we're now recreating that by saying copy stack is equal to stack again. So we've recreated that stack. So now copy stack and stack both have the same elements. Okay. So we're then going to test the copy constructor. Okay. Which is the function we're going to define down here. Okay. And basically we're going to send it some other stack. And we're going to test it here to see if not, the other stack is empty, then we're going to print out the top element of the stack, basically. Okay. So then we've got here, if the stack is the empty, if it's not the empty stack, then we're going to say that the original original stack is not empty, top element of the original stack, and print that out. Okay. We're then going to copy the stack into the dummy stack. Okay. Note that dummy stack had initial allocation of 100, maximum size of 100. When we do this copy stack thing, or copy stack to dummy stack, it's going to set it to 50. We're then going to go through and we're going to print out the same items again. Okay. So should be able to run this. Do the quick and dirty. Okay, looks okay. Okay, and we can see that our original stack should have been 56, 28, 85. It is. Let's see the top element first. The only way we can go is top to bottom. Okay, the other stack is not empty. And then it gives us the top element of the other stack we've copied to is 56, which is correct. Original stack is not empty, and then the top of the original stack again is 56. And then when we've copied over the dummy stack, it still is the 56, 28, and 85. Okay. So again, I think using an array is fairly basic, so it shouldn't be too bad to operate. So go through the book chapter, go through the examples that are there, and then on the problem set, we'll be doing some actual programs with this. Okay. Again, for the homework for all these data structures, you're going to have to get working implementations of these header files working. So make sure those are working before you move forward.